So now what we have is del u by del x, which is this large function, and del u del y, which is this tiny function, cute function. So now what we have to do is we have to use our Milne-Thomson formula. By the way, I forgot. I named this capital U, I named this capital V, this function like f is equal to u plus iv, right? And this is like that format only. This is something u without item, and this is with item, so this is like v. So I gave them different function name, u capital U and capital V. So now what I would give this name is, this function is capital F of z, right? So this was what small f of z, right? So now what I would do is, so this is right. This is this. So now what I'll do is I'll find f of z, which is integration of this and this. So this is the Milne-Thomson formula. Okay. So let's go. So f of z is equal to, since I'm finding with respect to this capital U and v, u plus v and u minus v I was finding. So I found this, right, from u capital U. I found this, right, which we have here. So we are finding capital V right now. Then we can divide by 1 plus I, and we can find small u and small v, which are going to be our orthogonal trajectories, right? So for that, first I have to find v. For finding v, but we are first we are finding capital V. So for capital V, it is with respect to capital F of z. So we didn't even have reached small f of z. So we are going to do it with respect to capital F of z. So we have found capital U, like we have capital U, right? We have u plus v, not individual u. So capital U's, we have found this del u by del x and del u by del y, right? After that, if we divide by 1 plus I, it would be solved. But for now, we have to find it with respect to this. So what we have to do is integration phi of 1 z comma 0. So x is z, y is 0, okay, minus phi 2 z comma 0 integration by the way. Oh, wait a second. Not like this. I integration of 5 to z comma 0 dz. And when we are finding v from u, we would use minus, and when we are finding u from v, we would use plus. And also so for phi of 1 would be u del u by del x. When we are finding v from u, when we are finding u from v, first function would be phi 1 would be del v by del y, because the v and y are related. Now here u and x was related, so that's why. And unrelated was second function, u del u by del y. So there it would be del v by del x. Okay, that's phi 2 in that v version. Okay, so now let's focus on our problem. Integration of phi 1 what it is, del u by del x, this large function. Okay, let's note it down. 2 sine square 2z, because x we have to write it as z and y we have to write it as 0. Okay, so 2 sine square 2z minus 2 cos h 2 into 0, wait a second, 2 into 0, which is going to be 0, but whatever, into 2 into cos 2 into 0, which is also going to be 0, plus 2 cos square 0, 2 cos square 2 into 0. Okay, by divided by cos h2 0 minus cos 2 into, wait a second, 2 into 0 whole square. I told you, anything multiplied by 0 is 0. Yeah, x into 0 is 0. So what will happen here is, if you like follow my channel from long ago, like you have like explored my thread, if you have ever explored my thread channel, you must have studied my hyperbolic series like notes. So where I given that, wait a second, you must have studied that cos hyperbolic x equal to e raised to x plus e raised to minus x by 2, and sine hyperbolic x is equal to e raised to x plus minus, sine is opposite of cos, so here plus opposite minus, e raised to x minus e raised to minus x by 2, right? So this is what you are going to use here. So let me zoom.